Okay, hello everyone. Today our topic is about electromagnets. Okay, so let's move to the first part, and here is about electromagnets. Okay, so as you can see here, there is a battery connected with a switch and connected with a coil, and here is a core inside of this, right? So last time we discussed about how the coil can work, right? Using the right hand grip rule, right? So you can find the current is moving like this direction, and here you can find the current is moving upward, and it becomes many loops, right? They form different loops. Okay, so maybe each loop can form a very small electromagnetic field. So if we add them together, so they can have a superposition that will make the magnetic field very strong, right? So using your right hand rule, you can say you're using your hand to grip the rod, right? And you can find, oh, maybe your four other fingers just like to rotate as this way, and maybe your like thumb just to point at to the left, right? So we can say, so the thumb pointing direction means the north pole direction, right? And here is the south pole. So it just seems to be a magnet, right? Like this way, here is a N north pole and here's a south pole. So it's just like this, it has a magnetic field, right? So this is the last time we had discussed about. And scientists has do many experiments to prove that, oh, maybe if we put a core into the coil, there has a very big difference. Okay. So what is the difference? You'll find that the magnetic field becomes very strong. Okay. So we can say, oh, if we pour a core like iron, like a copper, it can magnify the magnetic field. Okay. So this is for the core meaning in these places. Okay. So here you can say, oh, maybe here, if you want to make the magnetic field become stronger, you have two methods, right? Like before we said, you can increasing the current, right? Because one current can produce one kind of magnetic field. So each loop can form a magnetic field. So that means you improve the current, so the single magnetic field will become very strong, right? So if also you can increasing the number of turns in the coil, right? So if you have more turns and more like loop right here, that means your magnetic field can be superposition, right? And also today we have another method is to put a core inside of this, okay? So please remember that we have three put a core inside of this. We have three methods to increase the magnetic field, okay? So if you want to reverse the magnetic field direction, like here it is north pole on the left and the south pole on the right. If you want to make the south pole on the left and north pole on the right, so maybe you have like other muscle, like you're using your right hand grip rule, right? So maybe here your right thumb just pointing to the right. So maybe you can find, oh, right here we can just reverse the current direction, right? You can find here, if you're using your hand to doing like this posture, right? So we can say, oh, if you just reverse the battery like this, we can say, oh, here's a current switch or change its direction, right? So here we can using this method to reverse it. Okay, so this is for the second part of electromagnetics. Okay, so here is a like an application for the electromagnetic waves. And maybe here you can find here's a switch and here's a battery. And once you close the switch, you'll find that, oh, maybe current just flows out and to form a total loop, right? So you can find here that there's a coil and a core inside of this, right? So you can use your right hand grip rule, right? So you can point in every direction for the like the solenoid, right? So maybe here is for like this from the right to left. You can just imagine here there's a behind line after the relay, like here. The current just moving to here and then rotate and then rotate. So each coil has the direction from the right to the left current. Okay. So you can use your right hand grip rule and the four other fingers represent for the current direction. So current direction, you can find maybe you can raise up your right hand and four other fingers just pointing from the right to the left, right? And you can find that, oh, maybe your thumb is just like pointing to the ground, right? So like this way, you can just rotate it. Okay, so maybe you can say, oh, here the North Pole is this way and here the South Pole. Okay, so this way and using like a core to magnify the magnetic field, so it can make the very strong magnetic field, right? So here you can find, oh, the magnet has a very strong magnetic field. So here you can find the iron armatures has, or maybe it is just be like attracted by the electromagnetic field, right? So here you can find, oh, it is attracted and the magnetic field just attracted and to make it to this kind of a little bit of rotation. So you can find, oh, maybe here is a two contacts contact with each other, right? So you can find, oh, maybe here is a power supply, and the power supply also afford a current and to make a loop, and then electric motor can work. Okay, so this is how we can use this to like remote control the electric motor, right? Using a iron armature. Okay, so this is the way we can call the total parameters right here. We can call in this circle, in this blue circle, the total parameters inside with a relay. Okay, so you can find relay is using like this switch to control like this kind of switch, right? We are using contacts to become a switch, right? So we can say, oh, maybe here a relay just means using magnetic field. We can control the magnetic field and to control the machine, right? And control the machine, we can control the another kind of switch in another circuit, right? And then make the electric motor to move. Okay. So you can say this is a remote control for our daily life using like if you're in your room, you want to remote control your television to make it close, you can using maybe app on your iPhone, right? You can control this, right? This is for the magnetic relay. Okay. So here is also a usage or application for the magnetic relay. You can find that in our car, like in our electrical car, like you're driving a Tesla, like you're driving another kind of brand of electric car, and you'll find that maybe if there's an emergency happened, there's a coil, right? And maybe like there's a very strong crash on your car and your coil, maybe here the switch closed down. And the switch closed down, you can find, oh, maybe here's a coil just like attracted, make a make a current and right here and to attract the switch. And the switch is made by metal, right? So it is just closed. So maybe here it will have a bell. Bell will ring, and also maybe here it will control some electromagnetic system. And system can maybe give you a call to the remote center and they will give you a first aid and give you a security help. Okay, so this is how the magnetic relay can help in like the electromagnetic or like for the just magnetic usages for in our daily application. Okay, so we can say this is a kind of magnetic relay in our daily life. Okay. Okay, so this is for today's our lesson. I think the most difficult thing is to just remember how to increase the magnetic field in the coil, right? This is the first part. We have three methods, right? Like increasing the terms of the coil, like also increasing the current, and also you can just increasing putting a core into the coil, right? And if you want to reverse it, you can just reverse the battery, right? You can use it this way to reverse the current, and using right hand grip rule, your magnetic field will totally reversed. And also you can find there are two applications. One is relay, and the relay can be used in the electrical car system. Okay, this is for today's our lesson. So see you next time. Bye.